Okay, here we go. Review of neural transmission, the impact on our behavior. All right, we have to remember we're dealing with very, very complex behavior. So that, as you see in this picture with the synaptic knobs, it takes a lot of information. And we're just going to go through and do a quick review and a very simplistic view of what's going on. Right, we have to remember that we have the action potential. Here it is, the resting potential. It has to get to the threshold. We zoom up, and down, and then it needs to rest before a message gets sent down the axon. That's all powered by this sodium-potassium pump. So where does it go wrong? We've talked about the vesicles in terms of not simply having enough neurons available. We have it going across and having to attach at the receptor sites. Remember the all or none principle, you have to have enough going on there. And then we have the reuptake that occurs that could be blocked. Important concept here is to remember that things that come into that sense can be an agonist or it can be an antagonist. It stops the action, and this is going to pretend or increase the action. All right, here we go. This is in your book, basic information on the neurotransmitters, and I've added a few more, but this is the basic set. Important concept, is it telling it to go or is it going to tell it to stop? All right, the main one that gets looked at is GABA, and we're going to talk about that a little bit later. Dopamine, all right, can act in both ways. Lots of things that it does. We see that it's here in the limbic system, right? So we see that we have a lot of things listed in motivation, reward, and reinforcement. Okay, so can be replicated by amphetamines, things in terms of addiction. We find that it decreases in Parkinson's, and it has been found to have increased levels in terms of schizophrenia. Acetylcholine, big thing is the muscles, but also tension, arousal, and memory. Example here, we have the Botox, right? Freezes things in place, and some other drugs that do that impact the neural transmission. Serotonin, ooh, this is a biggie, all right? Depression, OCD, right? So we can see that not only is it in the limbic system, but that it deals with other kinds of messages sent to the brain. GABA, really important. It prevents overstimulation, and that's why we have a third of the neurons use GABA. Epinephrine, norepinephrine, they modulate mood arousal. So we know that that's in a different category that we talked about, that it is not a direct impact, but that it modifies other neurotransmitters. So we see that there's a whole series of clinical manifestations that are involved with neurotransmitters. Yes. Are there multiple neurotransmitters involved in the behavior? Again, we need to think about the complexity of the kinds of behaviors that we're talking about. That's all.